Hello and welcome to this lesson on circuit symbols, which is part of the circuit electricity module in GCSE AQA physics. So in today's lesson, if we've been successful and we've learned today, we should be able to understand the basic definitions of electrical quantities, detail the circuit symbols of electrical devices, and understand how to draw an electrical circuit diagram. So in today's lesson, we're going to be looking at the following parts of the AQA GCSE physics specification. So, to start off, we can look at a cell. Now, a cell is one device which produces a potential difference for a circuit, and a battery is a plural of a cell. So, a battery provides a higher potential difference and more energy than a single cell. Now, in a battery, the potential difference of each cell is added to find the overall potential difference of the battery. Now, the two main types of battery that are commonly used are single-use batteries and rechargeable batteries. Now, single-use batteries are a convenient source of power but are expensive in the long term, whilst rechargeable batteries can be recharged and are more economical in the long run, although they are initially more expensive to purchase than single-use batteries. However, they can only be recharged a number of times before they lose their battery life. So to clarify, a cell is a device which creates a potential difference. When this is placed in a complete circuit, a current will flow. And a battery is two or more cells put together in an electrical circuit. Now, electrons can be made to move in an electrical circuit when attached to a source such as a battery or a cell or a power pack, providing a potential difference. So this allows our electrical energy to be used in different electrical devices. Now, electrical devices are devices found in electrical circuits which convert electrical energy into other energy stores. So as you can see in this particular diagram here, you can see our electrical device of the bulb. So here, the energy starts as the chemical energy store of the battery or cell. Now the battery or cell puts the energy into the electrical circuit. Work is then done in the electrical circuit via electrical current. So work is done when charge is moved around the circuit. Energy is then outputted as a store of the output of the circuit. In this case, this is the light bulb. So the work is done in an electrical circuit by charged particles flowing. So we can say the work is done by the movement of charge. So as we mentioned, energy is outputted as a store of the output of the circuit. Now remember that energy cannot be created, it cannot be destroyed. So this means that the energy supplied by the battery equals the energy outputted by the outputs. Now this is an example of a closed system. However, the electrical circuit is in fact an open system. So what this means is that some energy is dissipated to the surroundings through the wire, i.e. the circuit gets hot. So in reality, the energy supplied by the battery or cell will equal the energy lost through the wires plus the energy outputted from the output. Now eventually all the energy supplied by the battery or cell is dissipated into the internal energy of the surroundings. Now, devices which transfer electrical energy into other energy stores include resistors, light bulbs. Now, older bulbs can be also called filament bulbs, rheostats, which are an example of a variable resistor, and fuses. Now, we can represent these electrical devices with circuit symbols so that they can be understood all over the world when they're drawn in diagrams, irrespective of their native language. And it's important to note that circuit symbols are constant over the entire world. In addition, we use electrical symbols as they are easier to draw than in a circuit and less open to interpretation. Now, circuit symbols therefore are easier to understand and quicker to draw. So here are the symbols you must be aware of. The cell, which supplies electrical energy to the circuit. The larger terminal on the left is the positive. The battery. It's made from more than one cell. Once again, the larger terminal on the left is the positive. The lamp or bulb, a device which converts the energy stored into light. The switch, this device allows current to flow only when it's in the closed or on position. The resistor, this device restricts the flow of current, for an example, to limit the current passing through an LED. The variable resistor or rheostat. This device with two contacts is usually used to control current. Examples include adjusting lamp brightness, adjusting motor speed, and adjusting the rate of flow of charge into a capacitor in a timing circuit. A fuse, a device which melts if the current in the device becomes dangerously high. A diode, a device which only allows current to flow in one direction. The voltmeter, a device used to measure potential difference, and this must be placed in parallel. The ammeter, the device used to measure current, and it must be placed in series. The light-dependent resistor, a device which converts brightness or light to resistance. A loudspeaker, a device which converts the energy stored from electrical to sound. A thermistor, a device which converts temperature or heat to resistance. So here's a quick review of all of the circuit symbols you need to be aware of for AQA GCSE physics. Now we need to be able to draw correct circuit diagrams when carrying experiments on electricity. We can use circuit diagrams as this allows electricians and engineers from all over the world to understand the electronics of the device even if they don't understand the language of the country. And this is important as you can then assess the dangers of the circuit and the requirements of the circuit. Now a circuit diagram shows how the components in a circuit are connected together. So the following is an example of a circuit diagram. So it allows you to determine the components in an electrical circuit and the layout of the circuit. Here's another example of a circuit diagram. Now it's important to understand that the circuit diagram allows you to determine the values of the current and potential difference for each component in the circuit. Now you can see it again here. It allows you to work out the different values of current and potential difference for each component. Here's an example of a simple series circuit diagram. A series circuit is a circuit with one big loop. So in a series circuit, the current is constant in the loop. In a series circuit, the potential difference is split over the output. And in this circuit, the current flows as the circuit is complete, and the diode in this example is in the correct direction. Now here's an example of a simple parallel circuit diagram. You'll note that the voltmeter is found parallel to the bulb. Now a parallel circuit is a circuit with more than one loop. So in a parallel circuit, the potential difference is the same across each path. But in a parallel circuit, the current splits across each path. So again here, we can see an example of a circuit diagram. Now the conventional current starts at the larger line of the cell, the positive terminal, and goes to the smaller line, the negative terminal. So as we said, going from the positive terminal to the negative terminal is known as the conventional current. Now you'll note that lines are drawn with pencil as straight lines and are completed. So here are our rules for circuit diagrams. Always use a pencil and a ruler. Draw these diagrams clearly and make them big. Always ensure the circuits are completed and ensure the wires are drawn as straight lines. The next, current flows from the larger line of the battery or cell around the circuit to the smaller line. So to summarise what we've learned in today's lesson, you should be able to understand circuit symbols, use standard symbols, and then you should be able to draw and interpret circuit diagrams with our following symbols. So if we've been successful and we've learnt in today's lesson, we should be able to understand the basic definitions of electrical quantities, detail the circuit symbols of electrical devices, and understand how to draw an electrical circuit diagram. Thank you so much for watching this lesson on circuit symbols, which is part of the circuit electricity module in GCSE AQA physics. Thank you so much and have a lovely day.